Okay. All right. So as I say, Cramer's rule, it wouldn't be something that we would normally solve for this type of 2x2 because you could do it by elimination pretty easily. But I want to show you how to do this with Cramer's rule on one that was simple that we already know the answer to. And then we'll apply Cramer's rule on more complicated ones. So the first thing that you're going to do is you're going to set up 3 matrices. And usually we call them just D, D sub X, and D sub Y. Didn't leave myself a lot of room for that one. Now, if you're really good, you can pretty much just imagine these 3 matrices without literally writing them down. But I'm just going to expect that you guys write them down, and if you feel like you want to just kind of imagine the matrices in your head, then that's fine. So the first matrix D is going to be, in this case, the numbers 2, 3, 1, and 2. So as I write those down, I want you to just kind of look at the original problem and just be able to tell where I got those numbers from.
I remember doing this.
You might have done this in Math 1. Yeah, you should have. I would have done it if I was teaching you in Math 1. So it should be something you guys are kind of familiar with, but I don't know if Armstrong taught it or not. But where did I get the numbers 3, 2, 1, 2? Or 2, 3, 1, 2?
The X and the Y values.
It's the coefficients of the original grid. So this is like the D is just these numbers, but without the variables. So you always want to have it in standard form, and you want X's and Y's just out of convenience of having it always done the same way. Reorder them. If something's scrambled, then you move it around. Now, this D sub X matrix is going to be the same values, but some things are going to be moved out. Do you remember? Yeah, what do you think? You remember what it is?
Is it going to be the X values with the 34 and the 22 instead of the 3 and the 2?
It's going to be the reverse. You're going to replace the X values with the 34 and the 22. So it's going to be the same matrix we just had, but instead of 2 and 1, it's going to be 34 and 22, but then we're still going to have the 3 and the 2 for that. So the thing is, the dx matrix, you replace the x coefficients. And then the dy matrix, you use your original matrix, but you replace the y's with like the answers. So this is now going to be 2 and 1 are going to be the 2 vertical numbers, but 34 and 22 are going to be your y numbers. So the dx, you replace your x's with the answers. For dy, you replace the y's with your answers. So now this is something that I said that many people can just kind of like one by one mentally just kind of imagine their 3 matrices and not actually literally write them down. Because the next thing what we want to do is we want to find the determinant of each one. And this is something that you could very easily do in your head. I mean, the numbers are kind of big on dx and dy, but they're not that bad. So what's the determinant of the D matrix? It's 1. Yeah, it's 4 minus 3. So that determinant is 1. And then I want the determinant of the X matrix. So that's going to be 34 times 2 minus 22 times 3. So 34, so that's 68 minus 66. So that's going to be 2. And then the determinant of the dy matrix would be 44 minus 34. So that's 10. So setting these 3 matrices up, it's just a matter of using the numbers in your equation. You just kind of mix them around a little bit. It's always got to be dx, replace the x's, dy, replace the y's. The determinant is always really easy to do on a 2x2. If we were going to do a 3x3, we would just use our calculator. And then here's how we get our solutions to the system. X, well, it's not exactly like what you're looking at. It's the solutions for x is going to be the dx determinant over the d determinant, which is 2 over 1. And the solutions for y will be the dy determinant divided by the d determinant, which would be 10 over 2. I'm sorry, 10 over 1. So x is 2, and y is 10. And as I said, this is like total overkill on this problem. Would have been way easier to just do this by elimination, multiply the bottom equation by -2, combine the two equations, the x's drop out. But I wanted to do it with one that we already knew the answer because we did it on the warm-up, so we knew what we were going to get. We knew we were going to get 2 and 10. Now we verify that this actually works, that some genius kind of crafted this method to work. Now, where it's going to be really cool is when you're doing this with something that would have complete decimal intersection points. Okay, so let's just make one up. Wyatt, make up an equation in standard form without large numbers, or just kind of something random, like something x plus or minus something y equals whatever. Just give me something.
4x plus 6y equals 10.
Okay. And what's the other one?
9x plus y equals 5.
Okay, I'm just going to throw a negative in there just for the heck of it and do 9x minus y equals 5. So my guess is this is probably going to have fraction answers. Now, we could try to do it by elimination. We could multiply the bottom equation by 6 and combine them and do it that way. But, you know, in this case, you kind of picked one that would have sort of been easy to do. If all of the numbers were like prime, we'd have to like change everything. We'd probably get a fraction for y. We plug that fraction in and solve for x. It'd be pretty bad. So in this case, we're going to do it with the determinants. So I'm going to write down my 3 matrices. We get 4, 6, 9, -1. That's my D matrix. The dx matrix will be 10, 6, 5, -1. So I'm replacing the x coefficients with the answer, which you can sometimes just kind of mentally do it in your head rather than physically writing it. The dy matrix, the 4 and the 9 are still going to be on the left like the original, but now 10 and 5 are going to go there. So for the dx, your answers go in for x. For the dy, your answers go in for y. And then we find the 3 determinants, which is usually pretty easy to do. This would be, let's see, -4 minus 50. 9 times 6 is 54.
56. Yes.
9 times 6?
54.
54?
You ever use the hand thing?
I never use the hand thing.
I do.
I probably should.
It's easy.
9 times 6, for some reason, I always like, that one never sticks. I'm always like 54, 56. So 9 times 6 is 54? Okay, so this is going to be -58. Okay, this one would be -10 minus 30. Okay, so that's -40. And then we've got 20 minus 90, so we got -70. All right, so those are my 3 determinants. And so the value for x is the dx over the d. So it's a negative divided by negative, so it's going to be 40 over 58. The solution for y is the dy over the d. So since it's negative divided by negative, it'll be 70 over 58. All right, so these are clearly both decimal answers. Now, the only way to know if this actually is right would be to either graph the system and just see whether or not it worked, or you just take it on faith and you trust Kramer and so like, oh, this Kramer guy probably knows what he's doing because he's got something named after him. But let's check. 40 divided by 58. Okay, that's a decimal that like is going to go on for a long time. I'm going to 0.68. If I just kind of truncated it 2 decimal points, 70 divided by 58 is 1.2. Okay. Now I could verify this by checking in my calculator and seeing if it's right. I'm just going to quickly graph it. So let's see. Go to Desnos. 4x plus 6y equals 10. Okay. So let's see. 4x plus 6y equals 10. So I recommend doing this on the homework is rather than trying to plug in your answers to see if you're right, just pull up Desmos on your phone or whatever and just, you know, see. Just graph it and see if their intersection's right. What was the other equation, Wyatt?
9x minus y equals 5.
Minus y equals 5. Okay, let's see. Intersection is 0.69 comma 1.2. Yeah, I think that's right. Let me look back. Yeah, 0.68. I didn't round it. I just truncated it. But yeah, okay. So it works. So obviously this system, again, on this type of problem, it was overkill. It would have been really nice to just do it the old way you learned in Algebra 1. But then this method, obviously, with the equation that Wyatt made up, it would have been kind of gnarly to do this because we would have gotten when we solve for y, or say we solve for x using elimination, we would have gotten something equivalent to 40 over 58. And then when we plug in 40 over 58 and solve for y, that's going to be kind of gnarly. So I think that doing it with the determinants is kind of nice because you don't ever have to deal with any fractions at all. It's just your answers are the fractions. You don't have to get a fraction and then plug it in and then try to work it out to get the other one or use a decimal.
Is that okay to leave with fractions, or do you want us to?
I'm fine with the fractions. The only reason I did the decimal was at the time we didn't know if this actually worked. And so I wanted to verify it with Desmos, and so I needed the decimals to know. But normally I just expect to leave them as fractions. I mean, reduce them, if you have to. But at this point, it's like, come on, you guys know how to reduce. So I really don't care if you do it or not.